Today we are going to cover all types of questions of position, displacement, velocity, acceleration that can come in your exams. From basic concepts to numerical problems, everything will be covered in this one video. So before I start solving this, if you're preparing for JEE or NEET and you feel stuck with concepts, strategy, revision planning or question solving approaches, then you can check out pracbee. At pracbee, students can book personalized one-to-one mentorship sessions with experienced mentors to get individual guidance based on their own strengths and weaknesses. Now with that said, let's get into the question and see the smartest way to solve it.
So the very first problem type is finding the instantaneous velocity or the instantaneous acceleration, and the second one is the finding the average speed during the entire journey. And then there will be motion in a circular path, and then they can ask us what is the distance covered, what is the displacement, or what is the change in velocity. All these types of question can be asked. Now let us see the very first problem type, finding the instantaneous velocity and the acceleration. So let us see the question. A particle is moving in one dimension under the action of a variable force. Its initial position is 16 meters right to the origin. The variation of its position with time is given by this, right? So x is equals to minus 3t cube plus 18t square plus 16t, where x is in meters, t is in seconds. The velocity of the particle when its acceleration becomes 0. So we have to find the velocity when the acceleration becomes 0, right? So here what we have to remember, that the instantaneous velocity is nothing but the rate of change of position. So dx by dt will give us instantaneous velocity, and instantaneous acceleration is the rate of change of velocity, dv by dt. And we have to find the velocity when acceleration becomes 0. So what we're going to do in this question, we'll find the instantaneous acceleration and let us check at what time acceleration is 0. So we'll get the time, then we use that time to find the instantaneous velocity. Let us see. So let us first find the instantaneous velocity. So the differentiation of t cube will be 3t square, differentiation of t square will be 2t, and differentiation of t will be 1. So we can say v is nothing but minus 9t square and plus 36t plus 16. So that is instantaneous velocity. Now if you differentiate again, then the instantaneous acceleration will be minus 18t plus 36. And let us find the time when this acceleration is 0. So when this acceleration is 0, t will be 36 by 18, which is nothing but 2 seconds. Now we got the time when acceleration is 0. Let us substitute this time in the instantaneous velocity formula. So v comes out to be at t equals to 2 seconds. It will be minus 9 times 4 plus 36 times 2 plus 16. So if we simplify this, so this will be 36 plus 16, that is nothing but 52 meters per second. So 52 is the answer of this question. Now let us see another question based on the same problem type. A particle is moving in a straight line. The variation of x as a function of time t is given as x equals to t cube minus 6t square plus 20t plus 15 in meters. The velocity of the body when acceleration becomes 0. Again, it is based on the same concept, so I'm leaving this as a homework for you. Now you know how to tackle these type of questions. Let us see this question. A particle initially at rest starts moving from a reference point x equals to 0 along the x-axis with velocity v that varies as v equals to 4 times root x in meters per second. The acceleration of the particle is, so we have to find the acceleration, and v is given as a function of position. So v is given as 4 times root x. Now what we're going to do, we'll differentiate this with respect to time. We will get the instantaneous acceleration. So dv by dt equals to 4 is constant, so d by dt of root x. So this will give us acceleration and dv by dt of root x. So the differentiation of root x with respect to x is 1 by 2 root x. Then we have to apply chain rule, then it will be dx by dt. Now this dx by dt is nothing but the instantaneous velocity. So we can write this as 2 upon root x times v, and instantaneous velocity is given as 4 times root x. So it will be 2 divided by root x, and v can be written as 4 times root x. So root x will get cancelled out, and we are getting 8 meter per second square as the acceleration. So we can say in this case the acceleration is constant, right? So it is 8 meters per second square. Now let us see another illustration based on the same problem type. The distance traveled by the object in time t is given by s equals to 2.5 t square. The instantaneous speed of the object at t equals to 5 seconds. So we have given the distance traveled, or you can say this is also the position, because the distance traveled is 0 at t equals to 0. So we can assume, we can say this s is nothing but the position of the particle. So instantaneous velocity will be ds by dt, which is nothing but 2.5 times the differentiation of t square is 2t. So it comes out to be 5t. And we have to, what is the velocity at t equals to 5 seconds? It will be 25 meters per second. And we know the magnitude of the velocity is speed, so speed is also 25 meters per second. So option 4 is the right answer. Again, it is based on the same concept, so I'm keeping this as a homework for you. You just have to differentiate x with respect to time, you will get the velocity. And then you can substitute t as 2 seconds, you will get the answer. Right, so yeah, again it is based on the same concept. Again, I'm keeping this as a homework for you. Just let me tell you the answer for that. Option 1 should be the right answer in this case, and in this question option 3 should be the right answer. Okay, right, so now let us see the next problem type, which is based on calculating average speed for the entire trip. A person travels x distance with the velocity v1 and then x distance with the velocity v2 in the same direction. The average velocity of the person is v. Then the relative relation between v, v1 and v2. Okay, let me first draw the diagram what we have. So let us say this is AB, which is having a length x, and then we have BC, which is having a length x. Now the particle covers A to B with a speed v1, and it covers B to C with a speed v2. Right, and what is the average velocity for the entire trip? It is nothing but the displacement upon time interval, right? So average velocity will be displacement upon time. So what is the overall displacement? It is nothing but 2x. It is going in the same direction. And what is the time? So we can say it will be sum of the time from A to B plus B to C, right? Now what is time from A to B? From A to B, the particle is moving uniformly with the velocity v1. So the time will be distance upon speed. Distance is x, speed is v1. So we can write this as 2x divided by distance upon speed, and this will be distance upon speed. Now this will give us 2v1 v2 divided by v1 plus v2. So this average velocity is given as v in the question. Now this will give us 2 by v is equals to 1 by v1 plus 1 by v2. So option 3 is the right answer. Now let us see one more illustration based on the same concept. A particle moving in the straight line covers half of the distance with the speed 6 meters per second, and the other half is covered in two equal time intervals with speed 9 meters per second and 15 meters per second respectively. The average speed of the particle during the motion. Okay, let me first draw the diagram. That is, this is A to B, which is x, and this is B to C, which is again x, right? So from A to B, the particle is covering this x distance with speed 6 meters per second. And let us say from B to C, the time taken is 2t, right? Let us assume that from B to C. So for half the time interval, let us say this is the time interval, that much, right? So this distance is covered, let us say BD, right? So BD is covered with a speed 9 meters per second, and DC is covered with 15 meters per second. So what we can say, B to D time is t and D to C time is t. So we can say x is nothing but speed into time. X is distance is speed into time, right? So it will be 9t plus 15t, right? So this will give us the relation between x and t. Now we have to find the average speed for the entire trip. So average speed is the total distance upon total time. So total distance in this case will be 2x, and the total time will be time from A to B plus time from D to D, B to D plus time from D to C. So this can be written as 2x divided by time from A to B is distance upon speed, which is x by 6, and time from B to D is t, and time from D to C is t. And we know the relation between x and t. So x is nothing but 24 times t. So let us substitute x as 24 times t. So this will become 48 times t, and it will be 24 times t divided by 6 plus 2t. So this will give us 4, and we will get 48 divided by 6, which is nothing but 8. So it will be 8 meters per second. So option 2 is the right answer. Now let us see one more illustration based on the same concept. A car covers AB distance with first 1/3 at a speed of v by v1, and the second 1/3 with v2, and the third last 1/3 with the speed v3 meters per second. And we have given v3 is 3 times v1, v2 is 2 times v1, and v1 is equals to 11. So basically we have given all the speeds, right? So v2 is 22, and v3 is 3 times 11, that will be 33, and v1 is given as 11. So that is given to us. So let us assume that the total distance is 3x. So it covers x distance with v1, x distance with v2, x distance with v3. So if you want to find the average velocity, that will be the total displacement upon total time. So total displacement will be 3x, and the time from, let me call this point as C and this point as D. Time from A to C is distance upon speed, and time from C to D is distance upon speed, and time from D to B is distance upon speed. So x will get eliminated, so it will be 3 divided by 1 by 11 plus 1 by 22 plus 1 by 33. We can take 1 by 11 common in the numerator. So we'll get 3 times 11 divided by 1 plus 1 by 2 plus 1 by 3. So that will be 33 divided by, and the LCM in the denominator will be 6. So 6 plus 3 plus 2. So it will be 33 times 6 divided by 11. So that will give us 3, and it will be 18 meters per second. So 18 is the answer of this question. Right, so I'm keeping this question as a homework for you because again it is based on the same concept. So in this case the option 3 is the right answer. Let us try to do this question. Again we have covered the same question. Like this question is similar to this one, right, which we have covered. Right, so let me just read out the question, and then you can try this question on your own. A horse rider covers half the distance with 5 meters per second speed. The remaining part of the distance was traveled with the speed 10 meters per second for half the time and 15 meters per second for other half of the time. And the mean speed of the rider average of the whole time of the motion is x by 7 meters per second, the value of x, right? It is again the same, only the values are different. Overall the question is same, which is same as this question, right? Okay, if you solve this, you will get 50 as the value of x. Okay, right. So let us see this question. A vehicle travels 4 kilometers with the speed of 3 kilometers per hour and another 4 kilometers with the speed of 5 kilometers per hour. Then its average speed. Okay, so we have given distance and we have given speed. So 4 kilometers and then 4 kilometers. This distance is covered with 3 kilometers per hour, this with 5. So average speed, total distance, that will be 8 kilometers, and the time will be distance upon speed plus distance upon speed. So that will give us 8 times 15 is the LCM, and we have 4 in the denominator, 5 plus 3. So that will give us 2. So 30 by 8, which is 3.75 kilometers per hour. So option 4 is the right answer. Okay, so I'm not doing this question again. It is we have covered the same question. I'm keeping this as a homework, and the answer for this question will be option number 4. Now let us see the third problem type, which is based on motion of the particle in a circular path. A clock has 75 centimeter and 60 centimeter long second hand and the minute hand. So 75 centimeter is the second hand and 60 centimeter is minute hand. In 30 minutes, the duration of the tip of the second hand will travel. The tip of the second hand travel a distance x more than the tip of the minute hand in 30 minutes. The value of x in meters. Okay, let us see. in 30 minutes, the minute hand will cover half the circle, right? So it will cover half the circle. So we can say if the radius is given, so this is nothing but the radius of that circle. Let me show you. So if this is the minute hand, the tip will cover half the circle in 30 minutes. And this radius is 60 centimeter. So this arc length will be pi times 60 centimeter. Whereas in the same time, if you consider second hand, so in 1 minute, second hand completes one full rotation, right? So in 30 minutes, the second hand will cover 30 full rotations, right? So it has covered overall how much distance? The tip of the second hand, it has covered 2 pi r, which is 75 centimeter times 30. And we have to find the value of x in meters. So we have to take the difference of these two, right? So what is x? It is the more distance covered by the second hand in comparison to the minute hand. So it will be 2 pi times 75 centimeter times 30 minus pi times 60 centimeter. And we have to find answer in terms of meters. So let us divide this with 100 so that we can convert this into meters. So pi will be common, and we will get 2 times 0.75 times 30 minus 0.6. Right, so this comes out to be, so this will be 3 by 4. This is 3 and this is 4. So this will give us 7.5. And we have 15 times 3 minus 0.6. So 45 minus 0.6. And pi is 3.14. So we have to find the closest answer. So 3.14 times 44.4. So this will be 139.4. So option 3, 139.4 meters. So option 3 is the right answer. Now let's see this question based on the same problem type. A cyclist starts from the point P of a circular ground of radius 2 kilometers. So radius is given as 2 kilometers. And travels along its circumference to the point S. So it is going in the clockwise direction and it reaches S from the point P while cycling in the clockwise direction. And we have to find the displacement. We know the displacement is the shortest distance between the initial and the final position. So this will be the displacement, and we have to find the magnitude of the displacement. So if you look at this right angle triangle, this is r and this is r, and radius is given as 2 kilometers. So that will be root 2 times r. So it will be 2 root 2 kilometers, or we can write this as root 8 kilometers. So option 1 is the right answer. Now let us see this question. A body is moving with a constant speed in a circle of radius 10 meters. The body completes one revolution in 4 seconds. At the end of 3rd second, the displacement of the body. So if the body covers the complete, if it has a one full rotation revolution in 4 seconds, so in 3 seconds it will be having 3/4 revolution. Again, it is based on the last question. If this is the circular path, and the particle starts say from point P and it is moving uniformly, so that will be the 3/4 rotation, right? So it is going like this. So here it will reach in 3 seconds. So the displacement will be this, right? So again it is r by r root 2, and in this case radius is given as 10, so that will be 10 root 2. So option 4 is the राइट आंसर।
तो ये था इस क्वेश्चन का कंप्लीट सॉल्यूशन। अगर आपने ध्यान से स्टेप्स फॉलो किए हैं तो आप सिमिलर क्वेश्चंस भी कॉन्फिडेंटली सॉल्व कर पाओगे। प्रैक्टिस करते रहो, क्योंकि जेईई एडवांस्ड में क्लैरिटी और अप्रोच सबसे इंपॉर्टेंट होती है। अगर वीडियो हेल्पफुल लगा हो तो लाइक करें, अपने फ्रेंड्स के साथ शेयर करें और प्रैकबी चैनल को सब्सक्राइब करना ना भूलें।